Greetings, welcome to the Johnson-Kendrow video hour. Minus Kendrow today, Johnson on my own here. We are teaching section 7.3 part 2. We're going to graph some logarithms. I'm going to start with an example to show you the relationship between exponentials and logs, and hopefully that will help you identify some of the features that are appropriate for these logarithm graphs. And the whole purpose of that is to show that these two things are inverses of one another. So I'm going to start by doing a simple graph of an exponential, y equals 10 to the x power. I'm going to just choose some simple values, -1, that's going to move that 10 to the bottom, that would be 1/10. Anything to the 0 power is 1, and 10 to the first will be 10. And I know that's only 3 points, but hopefully we remember our exponential ideas. And that should be a growth graph, and that should have a horizontal asymptote at y equals 0. Now, if we were to find the inverse equation of that, y equals 10 to the x, this is obviously my y value, this is my b value, and there's my x. So if I were to rewrite that in log form, that would say log base b of y equals x. And for the inverse function, I would want to flip-flop my x and my y. So if you think about that, our inverse equation is log base 10 of the x value equals y. Do remember that when it is a common log base 10, you will often see that with no base written. So this is the same equation. That means this blue function and the one I did in the green are inverses of each other. And remember, that is just another way to write that exponential function. I don't need to plug any values into that equation because I'm just going to take that red t-chart that I have on the left and I'm going to flip-flop those. 1/10 would produce -1, 1, 0, and 10, 1. And if I graph that, you will notice it does look like it is reflected over that diagonal, as all inverses should be. And we are going to have a vertical asymptote for the log graphs at x equals 0. So I don't think we've done any functions yet this year that we have had a vertical asymptote, but now we do. So on the exponential graph, it is y equals 0, and on the logarithm graph, it is x equals 0 because it is a vertical asymptote. Okay. So let's get into some examples how your homework questions and your test and quiz questions are going to look. They're going to ask you to graph just a logarithm. So let's start with no shift here, y equals log base 2 of x. Here are your steps. Write the exponential function that goes with that. So be careful, the base to the power is the number. 2 to the y equals x. And I know that that looks a little funky. It's because of the placement of the y and the x that those are flip-flopped. You're going to make a t-chart for that function, and what's weird about this is we're going to pick for the y values. We're going to pick for the y values because those are the exponents, and then we will graph those. So I'm going to, again, start pretty simple, -1, 0, let's go 1, 2, and 3, and those are exponents. 2 to the -1, that means move it to the bottom. That's going to be 1/2. 2 to the 0 power, anything to the 0 power is 1. 2 to the first is 2, 2 squared is 4, 2 to the third is going to be 8. Then when you graph those, make sure that you are realizing that we are now doing x comma y. Don't do y comma x, you'll end up with an exponential. 1/2 should be at -1, 1, 0. By the way, every log will have an x-intercept at that location. That's because of that 0 power relationship. 2, 1, 4, 2, 8, 3. I'm going to connect my dots, and I'm going to draw my asymptote. The equation for that asymptote is x equals 0, and that is because it is a vertical line. So now we'll add the shifting idea, so very, very similar to many of our other shapes that we've worked with. I'm going to use the very same ideas here. Left or right will be in the parentheses. That's very important. So if you see something that doesn't have parentheses at all, for instance, log base 2 of x plus 5, if there's no parentheses, that's actually a k. So just be careful. Left or right for the shift in the parentheses, and remember that is the one that is backwards from what you might think. If you see minus, you're going to the right. If you see plus, you're going to the left. K value is going to be up or down. We will use the shape chart idea. The shape is set by log base b of x, but remember that we're going to make our t-chart from the exponential equation and picking for the y value. Okay, so in this function, this is a shift to the right 2 units. I'm going to wait and do that at the end. And same here, this is an up 3 shift. I'm going to wait and do that at the end. The shape would be set by y equals log base 6 of x, so excluding the shifting. The base to the power is the number 6 to the y equals x. And I'm going to make a t-chart, picking very simple values, and I'm picking for the y, first time ever. -1, that's going to be a fraction, 1/6. Anything to the 0 power is 1. Every single logarithm has an x-intercept at that location. 6 to the first is 6. 6 squared is 36. Too big for me to fit, but I will have the right idea at least. 1/6, -1, 1 0, 6 1. Keep in mind that these are all pre-shift. It would, I'm just going to do this really lightly, it would look like this. And it would have a vertical asymptote at x equals 0, but we have to shift it. So I'm going to take all of the dots I just plotted. They're all going to go to the right 2 units and up 3. 1 2, up 1 2 3. Shift it right 2, 1 2, and up 1 2 3. Put a dot. I'll just do my best here with my 1/6. 1 2 3. Now when we did our exponentials, we talked about how shifting will affect your asymptote. We definitely are going to have a shift that affects our asymptote here, but it is different than exponentials. This time we have a vertical line. A vertical line is going to be affected by any shifts right or left. So we actually are going to have to slide that over to the right 2 units. So you may want to make a note of that. Your k values, in fact I'm going to scroll back up. Our k values do not affect our asymptote. That's how it was for exponentials. Our h values will change the asymptote. So that's kind of interesting. I do want you to draw your asymptotes in with a dotted line. That will help you get the proper shape for the graph. Make sure you've got arrows on both ends. Do your best to make that thing approach the asymptote, but never cross it. The asymptote then must be x equals 2. That graph went to the right 2 units. That's going to help me with domain and range as well. X's are to the right of 2, so greater than 2. And the range values, I think we're going to have all real numbers. And you might notice that those are flip-flopped from the domain and range of exponential functions. Go figure. Last thing I have for you here is just a chart that might help you keep your things straight for logarithms that are shifted or not shifted. And I think I'll leave you with that. Ta-ta for now. We'll see you in class.